High School. This is Mr. Ayton, and we are in Week 3 Chemical Reactions. And this week we're going to be taking a look at redox reactions. In the previous weeks we've taken a look at precipitation reactions, and what were we looking for to identify a precipitation reaction? It was when we had two aqueous solutions coming together to make a solid. Now, in a redox reaction, what are we really looking for? We're looking for a solid that's added to an aqueous solution. Let me give you an example. That would be like a metal solid, like zinc or something like that, that's added to a positive cation, an aqueous solution. And what happens here in this reaction is our metal, which had no charge at the beginning, ends up getting a positive 1 charge because it lost electrons. The cation, which had the positive charge, ended up gaining electrons and having a 0 charge at the end, which meant it became a solid, a liquid, or a gas, whatever it is at room temperature. That's one of our reactions, which is a redox reaction. The other one is when we have a liquid or gas, in the same respects as a solid added to an aqueous solution, but a liquid or gas added to an aqueous solution. An example of that would be like a diatomic, like iodine or like bromine, something that is a liquid or gas at room temperature. And we're adding it to an aqueous solution, an anion with a negative charge. We see what happens to the diatomic. That ends up gaining electrons and becoming a -1 aqueous solution, or negative charge. The anion, which was aqueous and had the negative charge, ended up having a 0 charge and becoming a liquid or gas, whatever it is, again, at room temperature. So let's take a look at our reactions for this week. The first reaction is a bar of zinc, we see that solid right there, is immersed in a solution of copper 2 sulfate. And so what happens is we have our solid zinc, which has 0 charge on it. And it's added to a solution of copper 2 sulfate. Now the sulfate will end up being a spectator ion here, because since we have a metal, we need to exchange it with a metal cation. And so zinc and copper +2, which is aqueous. The zinc ends up getting a charge. What's zinc's charge always? It's always +2, which means that will become an aqueous solution. Copper ends up becoming a solid at the end, which means copper ends up having 0 charge at the end. If we look at balancing this, there's 1 atom of zinc at the beginning and end, 1 atom of copper at the beginning and end. Our charges are the same. It's +2 at the beginning, all of +2 at the end. So we're done balancing this equation. The next reaction we have is a piece of solid zinc is placed in a solution of 2 molar hydrochloric acid. And so what happens here is, we have a solid piece of zinc with 0 charge, and it's placed in a solution of hydrochloric acid. Since hydrochloric acid is a strong acid, we'll put H+, which is its aqueous cation. Zinc ends up getting a charge. With zinc's charge always, it's always +2, and that will become an aqueous solution. Hydrogen +1 will end up becoming H2 gas, which is the diatomic hydrogen gas, has 0 charge on it. That's what it is at room temperature. Now we do have to go back and balance this. We have 1 zinc at the beginning, 1 zinc at the end, 1 hydrogen at the beginning. There's 2 hydrogens at the end, so we need a coefficient of 2. And that balances out our charges as well. We have +2 at the beginning now. We have +2 at the end. So these are redox reactions. Tune back in next week for some more redox reactions, and have a good night.